0, all engine running.
The University of Buffalo Spacepole's RoboOps team has been hard at work designing, building, and testing the various mechanical, electrical, and communication systems of our rover. Utilizing the engineering machine shop, our rover's chassis and center axis pin have been machined and assembled, with suspension, motor mounts, and wheels currently in production. Our goal is to complete these components and assemble the rover by April 1st. The components for the rover's power system have been selected and obtained. Installation will begin after the rover chassis has been fitted with suspension and motors. In the coming weeks, the team will be completing assembly of the rover so that the communications team has ample time to begin their initial testing. Concurrently, the mechanical and electrical teams will be testing and evaluating their respective systems and redesign as necessary.
The electrical team has worked closely with both the mechanical team and communications team to select components that will create a unified set of systems. One of the biggest challenges faced was choosing motors that met the torque and speed requirements without overloading our power budget. Each of the 4 DC motors will be driven through an individual motor controller channel to allow for simplistic tank-style steering. The computer was selected for its low power consumption without sacrificing computing power. A majority of video processing will be done on board the rover to allow for less data streaming. The processor selected is one of AMD's quad-core APUs paired with 8 GB of RAM and a solid-state drive for optimal computing. The electronics cooling system has been debated heavily. The current plan is to embed filtered fans on the chassis to flow air across the components. A self-contained liquid cooling system is also being investigated. The final part of the design to date is the I/O panel. This 3D printed panel on the rear of the rover chassis will allow for easy connection to the onboard computer during field testing. Looking ahead, the main objectives for the electrical team in the coming weeks is to develop a wiring harness and install all electrical components in the rover chassis.
The computer on the rover will be running on Ubuntu, while the home computer will have Windows 7 operating system. This is the interface that we'll be building upon. I'm able to stream the video from the other computer using a webcam over the internet into our interface. We will be controlling the rover using a Logitech joystick, which the interface is currently able to take input from. Further ahead, we want to add more options to configure the rover remotely using this very interface, with options like maximum speed, maximum turn, etc. A second joystick will similarly control the arm.
The mechanical systems team's responsibility is to create a rover that is not only light, but strong. We have to work in unison with the electrical and communications team in order to make sure that all the components fit and work properly. In order to build the best possible rover, we had to look at the design process as not only mechanical engineers, but also material scientists. One aspect of which is heat treating after the aluminum of our chassis has been welded. As the material is welded, it actually loses some of its aged properties, which makes it reliably strong.
UB Spacepoles are excited and eager to continue working hard toward our goal of a winning rover. We would like to thank our generous sponsors for their support. We would also like to thank and acknowledge our faculty advisor, Dr. Kevin Burke, for his outstanding support for the team, as well as Dr. Karthik Dantu for his assistance to the Communication Systems team. Be sure to follow our team's progress on our website and our Facebook page. Thanks for watching, and we'll see you in Houston.